Okay, we are live. Let's make sure everyone's good. I think so. Looks like it's all right. So let's talk about the weather for this evening, ladies and gentlemen, as we get ready for the upcoming weekend. It's going to be our first real weekend where we're going to be dealing with real hot and humid weather conditions. We're already preparing here with fans in the window, getting the air conditioner clean, making sure that's all set up. Make sure your vents are good too. You'll be surprised what could get in there. And it's going to be one of those weekends that the first hot day is always the most difficult because your body isn't accustomed to the hot and humid weather conditions. And so there's a greater shock to the system because of that. And I would not be surprised if we have some reports of some heat related illnesses combined with everything else that's floating around out there right now for Friday, Saturday, and Sunday. So let's talk about what is happening right now. And let me pull up this data. And as always, I'll go over the basics, what I've been looking at, and then I'll take your questions, and then we'll see where we go from there. Okay? So, and then I'll follow up on the premium chat first, and then take the best questions from YouTube, which I see all you guys out there. Good evening, everyone out there. So let's get ready and rumble. Now, this warm front right here is marching its way along and is being enhanced by a short wave, which we can see real nicely on the water vapor satellite picture right here. You can also make it out pretty nicely here at 850 millibars. Okay, see that little negatively tilted trough? This is enhancing the thermal gradient that is in place over the region. You can see first with the moisture transport, and then at 850 millibars with our temperatures. In fact, let's zoom in a little bit here. Take the radar off, and you can see the introduction of that short wave and the enhancement of the warm air transport. And the combination of those factors is supporting increase in precipitable water values, and that is leading to rainfall at times becoming heavy right around this nexus here. Now, if you translate this towards the coast here, we're looking for tomorrow morning, especially between 5 a.m. and 8 a.m., from southeastern Pennsylvania through central and southern New Jersey, of periods of moderate rainfall, because that short wave at 850 millibars is basically going to track right across the southern border of Pennsylvania through southern New Jersey and out into the Atlantic. While that's happening, the rest of this warm front will be lifting northward. So this rainfall will not be as heavy as it's moving through New York City and Connecticut. Therefore, looking for less rainfall out of this threat out of that. But for central and southern New Jersey and southeastern Pennsylvania, could see close to an inch of rain out of this before it's done tomorrow morning. Now, the NAM seems a bit too aggressive here with pushing as high as 1.5 inches of rain. The other models are starting to catch up, so I like the idea of somewhere around 1/2 inch to 1 inch of rain, isolated amounts, possibly over 1 inch, focused over basically the Philadelphia metro on south. And then that clears out. And we start to transport our tropical air mass from the Gulf of Mexico right into our neck of the woods. And what that leads to is a steady rise in our 850 millibar temperatures. We really start to feel that influence on Friday, where our temperatures pushing into the 80s. Take a look at Saturday. You're talking about 850 millibar temperatures right around the I-95 corridor of around 21 degrees Celsius. Now, 850 millibars with optimal mixing at 21 degrees Celsius, that supports temperatures basically between 90 and 94. So I added in the fact that we're probably going to see some scattered cloud cover, and watch out for a sea breeze front right along the immediate coast. I'm thinking upper 80s to lower 90s, heat index somewhere between 93 to 96 degrees from New York City to Philadelphia on Saturday afternoon. Do not be surprised if we get a few isolated thunderstorms out of this. And let me show you why. And let me see and pull up. Here we go. We'll jump to 78 hours. Load it real fast. As fast as I can go. And sometimes this takes a little bit longer than I like, but what are you going to do? Okay, so here we are on Friday, and you can see right here. There we go. Okay, so here we are on Friday. You can see where our heart of our warmest conditions are on Friday afternoon. And notice our thermal gradient. So this isn't as impressive on Friday, right? But you can see where you can have the influence from the Atlantic Ocean here. Now let's take a look at Saturday. And you can really see it here. This is beautiful right here. Okay. You see this signal right here? This is a perfect example of a sea breeze front. Okay, a rapid drop off in temperatures. And you have your forecasted temperatures anywhere between 92 and 95 degrees. Again, I think this is a little bit too aggressive, just a little bit, but not too far off. So I wouldn't be surprised if it's between 90 to 93 degrees rather than 94, 95. But what catches my eye is this intense thermal gradient right here with our sea breeze front. You have temperatures close to what we call the convective temperature, which means it's very close to supporting natural instability, rising motion in the atmosphere, and that in itself would support a pop-up thunderstorm or two. Then you add in this type of thermal gradient, and you're setting up a nice little stage where you can get a line of thunderstorms forming, let's say, around Long Island, especially the South Shore of Long Island, and from Monmouth County down through Ocean into Atlantic through Cape May County, if we get enough instability in the atmosphere played out. So it's certainly something just to keep an eye on in that environment. This is a humid air mass, a tropical air mass, and one that we're going to have to be really keep an eye on evolving here. That is the first wave. By Sunday, you have warm enough temperatures to again support that same environment. But look what's coming in from the west here with our cold front. So I see an environment where we have enough instability in the atmosphere to support a line of showers and thunderstorms. And when I take a look at 500 millibars for this event, first of all, notice we don't see a deep trough here. This environment plays in perfectly with the setup that we've been talking about with the summer pattern. Western Atlantic ridge tries to flex. Troughs dig first into the plains, lift up towards the Great Lakes, intensify in the Gulf, in the Canadian Maritimes. That sends your cold fronts trying to dive south and then stalling out and washing out. So you set up an environment here at 500 millibars is not all that impressive. But take a look at 850 millibars. A little bit harder to pull off here. 1 second. Okay. And notice this trough is a little bit sharper. And the lifting's a little bit stronger. And then you jump at the same time period to the 850 millibar thermal gradient. You can see this is well supported cold front at the lower levels. So the next thing you want to check in this type of scenario is what about the 850 millibar winds? So let's pull that up. And right here, you can see that it's not tremendously strong, but we have enough vertical wind shear here to support an environment where you have instability, plenty of moisture, which, by the way, let's take a look at the precipitative water values. this time period. And there we go, right here. And you can see it maxes out close to 2 inches as this cold front moves through. So all this tells me that you have an environment that is favorable for a line of thunderstorms that features very heavy downpours, frequent vivid lightning, small to moderate hail, wind gusts over 40 miles per hour, potential for some wind gusts pushing over 65 miles per hour and downburst wind gusts. And the type of torrential rainfall that could lead to 1 to 2 inches of rain in a very short period of time in some of these thunderstorms. So it's not a widespread severe weather event, but certainly Sunday evening is going to be a rather stormy one. And this whole environment, starting on Friday, if we want to backtrack here, it's precipitative water values basically handing around 1.5 inches until we maximize the cold front, pushing us up to 2 inches. So this is a very humid environment. So Friday, Saturday, and Sunday will likely feature foggy mornings, humid, muggy afternoons, and I'm watching out for an isolated thunderstorm here and there. Saturday, again, with the sea breeze front, probably watch out for an isolated thunderstorm popping up, but not a washout this weekend. This weekend will be nowhere near like a washout. What it will be is a typical summer weekend where you have your temperatures pushing in the 90s. If you hear a rumble of thunder, head indoors. That's basically the rule. That's going to be the rule for the summer, so definitely keep an eye on that. Meanwhile, I want to touch on one thing with the tropics here because I've seen a lot of nonsense floating around on social media. What else is new? With individuals posting the GFS from 10 days out, 15 days out. Let me show you one example here. I'll pull it up here. And let's see, we'll go with a really old model solution. All right, so people were posting this up here. And they've been claiming, oh, look, there's going to be a major hurricane heading up towards Florida, heading up towards the Central Gulf Coast, so on and so forth. This is a good learning moment for everyone. The GFS has a really, really difficult time with warm core lows, mostly due to the fundamental way that it handles the physics with latent heat release. And it produces what I would call, I'm going to date myself here, called a murficane. Before the GFS, there used to be the MRF. And the MRF used to produce, after 5 days, no matter what time of year, a hurricane. Sometimes it produced a hurricane right off the East Coast. Sometimes it right over the central part of the country. So it was kind of laughable. So after 5 to 7 days, it produces a warm core low for no apparent reason. That type of error obviously has been reduced as time has gone by, but still becomes a theme for this model suite. And it's kind of like a curse that just doesn't leave the model guidance. I think it's the fundamental nature and way that the model data, which is driven by physics equations, handles convective heat release, handles the warm core low nature, and then produces this type of erroneous solution. So when it comes to tropical forecasting, the first rule, never trust a warm core low solution until you actually have a warm core low to forecast for. You could use the guidance to say, hey, look, this environment is favorable, but you never want to make any declarations of, oh, the region could get hit by a hurricane, okay? Because the fact of the matter is that there are so many factors to consider before we even get to that point of a landfall that it's really irresponsible to make any type of declarations, and certainly not to post anything like an image like that online, because it creates a lot of hysteria and concern and well, it's a scare tactic. It gets you to click on their stories and you read it, right? What you want to do in this scenario is take a look at what's going on in the tropics. And what we have here is generally unfavorable environment, which you would expect for this time of year. So naturally, people are going to focus on this area right here. And you might say, hey, look, Stephen, this could be a development. Well, it could be. We certainly have some convection and a little twist, but this is a cold core low pressure system. It's not a warm core low pressure system. And it is associated with an upper level trough that is swinging through Central America. And you also have shear in place here with a weak subtropical jet stream, but not exactly the best environment for development. So, could you see something form out of this? Yes, you could. Statistically speaking, climatologically speaking, if you're looking for development, you're looking for somewhere in the Western Caribbean, the Bahamas, and the Gulf of Mexico this time of year. So, could something bubble up? Absolutely, especially with a stationary front hanging around here. But, let me refresh this real fast. But, it's going to take a long time for development. And there are so many factors like dry air that's coming in from Africa via dust to really inhibit development any further. So my point is that look at the environment first, look at the observations first, and then look at the models to see which one makes sense. And honestly, right now, the European model guidance makes the most sense. The rest of the tropical Atlantic is pretty quiet. This is your intertropical convergence zone right here. This will lift northward as we go through the summer as normal. And this is what's left of our subtropical jet stream here, which again is pretty weak, a perfect signal for La Nina. So let's see, I think that is pretty much everything I wanted to cover for this evening on my own before taking your questions. And here's our rainfall coming in. Nice little swath of moderate to heavy rainfall. And one way to check to see if the radar is picking up the rainfall correctly is to look at your observations. And you can see over Ohio, we have reports of heavy rainfall all lining up to head right towards the southern border of Pennsylvania and heading right towards the Philadelphia metro for tonight and tomorrow morning. So now, let's take some of your questions, see what we got here. Let's see here. Let's see. So today is like the last day with dew points in the 30s until late summer, fall. I wouldn't go that far. I would not be surprised if we see more days like what we've seen today, at least through the middle of June. I think that we're going to be on a seesaw back and forth. I think we're going to be in a real battle zone for much of this summer. When it gets hot, it is going to be really uncomfortable with humidity. But then we're going to get knocked down pretty good. And that's going to lead to some dynamic severe thunderstorm events as well. Let's see. The 500 millibar and 250 millibar level look pretty zonal right now. I take that as not going to last. Actually, I would expect that the 250 millibar level will become more and more, what's the word I want to use? It would become less amplified at 250 millibars. I think we're going to see a lot of our amplification more at 700 and 850 millibars, where we get that lower thermal gradient interaction. 500 millibars is still questionable. If we're going to see anything, it's going to be in the polar jet stream. What factors are you looking for the potential for severe weather on Sunday? What factors could cause the threat to increase, decrease? Honestly, what has my eye is the precipitative water values I was showing you. I don't see this as an event where we see significant vertical wind shear, much like the other event. But we might see a little enhancement at 850 millibars leading into the event. So we'll keep an eye on that on Saturday morning, see if the models start picking up on that. But what really catches my eye is the precipitative water value, because what happens is that all that tropical moisture is being lifted up, and it's lifted up into a colder environment, and it has to slam towards the surface. And that leads to downburst wind gusts, and it leads to thunderstorms creating bow echoes. So while I don't expect a widespread severe outbreak out of this, I do expect an environment where we will see some severe thunderstorms on Sunday evening, but the primary concern will be the heavy downpours, considering you're lifting close to 2 inches precipitable water value, and that squeezes out anywhere from a quick 1 to 2 inches of rain very quickly with this line. Most of Sunday is going to be just fine in terms of outdoor activities. Maybe a few rogue thunderstorms out ahead of the cold front interacting with outflow boundaries and the sea breeze front and stuff like that. That's one thing to also we have to get used to, is that we're going to be dealing with a lot of these mesoscale boundaries all around the region, which can create a lot of volatility in the forecast in terms of expectations for thunderstorms. Friday will be humid, but not as humid as Saturday. Saturday is going to be really, really humid. Do you expect training of thunderstorms this weekend? I don't think so, with the way that the front is going to be moving, the progression is going to be moving. If you're going to see training thunderstorms, it's going to be associated with the sea breeze front on Saturday, but I have very low confidence of that. And the long range thoughts for Memorial Day weekend, or is it too far out? Preliminary, it looks like it's going to be a warm weekend. I don't see it as being a wet weekend, though, so that's certainly some good news. I think that we're going to see a building ridge from the Western Atlantic, and that may cause a stalling of a backdoor cold front where you get some showers lingering around New England, but we're fine. But we got some time to wait before we get to that point, so definitely we'll be keeping an eye on that. But I definitely like the idea of above normal temperatures for that period. Let's see what we got here on YouTube. Let's see here. With the storms we had on Monday, that's the start of severe season for us. Yeah, I would say it's the start of a severe season for us. Yeah, sure. Actually, we've had severe thunderstorms before that. But I know we're still a week away from Memorial Day weekend, but wondering your thoughts. Everyone wants to know about the holiday weekend, and usually it revolves around whether or not you can have your barbecue outside. I'll tell you what. Let's take a look at the 500 millibar level using the European ensembles guidance, as that's been the most stable guidance that we've had to use of late. I'll move all this while I get some water. Okay. So let's get to our holiday weekend. Okay. So this is the type of environment that we're going to be dealing with here. We definitely have signals here for a Western Atlantic ridge building. You have a deeper trough out here in the west, which is typical of this type of La Nina pattern. Notice we have a bit of a trough here out towards the Western Atlantic, but it's not very deep. This environment, more zonal here. I would not be surprised if we have some sort of stationary front set up right around from, let's say, Lake Ontario through Massachusetts. And we are on the warm side of that, based on the Western Atlantic Ridge. And 588 is a pretty good height to build up for the ridge for this time of year. This is probably an anomaly here. I would say right in this area right here, you have your Western Atlantic Ridge. Humid air is probably driving northward. Definitely a warm weekend. I don't see this as being below normal. The only thing I would say that would be a fly in the ointment might be a pesky backdoor cold front trying to create a little bit of mischief for the region. But other than that, this looks like a warm weekend and generally a dry weekend, considering where the ridge axis is and how it's developing. So it looks like that only intensifies as we move forward. So we're dealing with the building Western Atlantic Ridge. This is atypical of a La Nina type pattern. Let's see. And yes, definitely, well, the potential. Now, this is not a guarantee, but the potential for some severe thunderstorms for this weekend. That's definitely true. Okay. Let's see. Rob asks, Stephen, question about precipitable water values, or PWAT. Okay. In the past, you have discussed your theory that urban interference, in addition to some climate change, is increasing PWAT values historically. Is there a limit to how much PWAT values the atmosphere can hold? In the future, with additional buildings, what do you see as a potential high range for PWAT values for the tri-state? Oh, this is a good question. This is a toughie. All right, let me see here. Okay, so let's break this down, because this is an excellent question, because it revolves around climate change and everything else. Okay, so first of all, you have to consider how we're building our infrastructure compared to the past to now, and there are different factors involved here. But you're still adding heat into the lower levels of the atmosphere, so you're able to retain more PWAT values, and what that leads to is a constant feedback. Back in the mid 80s, around Freehold, New Jersey, where I grew up, where I live now, it was potato farms. It was corn. Most of the houses that you have built here, they were all corn. So you had more radiational cooling. It got colder, which means that you had a better potential for drier air building in, which means you had less of an ability to retain moisture, and so you don't get that feedback result. But that's gone now. Now, instead of cornfields, you have houses with heat and pavement and electricity running. So your boundary layer is naturally warmer. You have more roadways. You got more highways. You got a lot more traffic on Route 9. You have a mall. You have more houses getting ready to be built right around Freehold Mall. In fact, I think they're putting in like 200 or 300 new houses. Those factors all combine to lead to a urban heat island effect that feeds back on itself. It makes it more difficult to clear out the low level moisture in the atmosphere. So you got that factor. Then you have climate change, and you have a environment where you're able to increase your 500 millibar heights. And as a result, your capacity to hold more moisture in the mid levels of the atmosphere increases. So you have an influence in the lower levels and in the mid levels. And by the way, this is why I'm very much against using high temperatures and record high temperatures and stuff like that to measure global warming influence, because it's extremely volatile, and it can be enhanced significantly just by where you put that thermometer and where you're comparing an environment from not so many buildings to a whole city now. So I think that measurement and using that measurement is fraught with a lot of error. So I don't like using it. And people get confused saying that, like, hey, you're denying climate change. No, I'm disagreeing with how you're explaining it to the general public, because it leads to far too many questions and too many errors. Not to mention the fact that you have limited data the further back you go, and so you're trying to compare old data to new data with less spatial ability, and so therefore greater error. But with precipitable water values, what I love about using this metric is that you don't need perfect surface observations. You just need to understand the basic equations of the atmosphere and how 500 millibar works, and how that measurement works, and what that translates to in the ability to hold the atmosphere. Look at it this way. Temperature measurement and using temperatures as a way to measure global climate change is like trying to measure water, okay, the temperature of the water. What I decided to do is say, no, let's not measure the temperature of water. Let's measure how big the bucket is, because the bucket is stable. So with a stable measurement, it doesn't matter whether or not you put the thermometer by an airport or next to a horse carriage or what. It doesn't matter, because your 500 millibar measurements are stabilized, and so your equation is stabilized, and so therefore your explanation of how the climate is changing is stabilized. So with that, back to your question of where our maximums could go, typically I would go with a ballpark at 3 inches. Now, in tropical systems, which is a kind of an outlier, okay, because we don't see it all the time, you could easily push 4, 5, 6 inches in terms of precipitative water values. That is a rare case, and it's something that I would not use as an example, because it's such a rare situation. Okay, but in terms of thunderstorm development, I've been monitoring this, and I've been seeing more and more support for 2.5 inch type precipitative water values involved in just average cold front passages. And if our environment continues as it is, we can certainly see 3 inch precipitative water values as an average with cold front passages, which tells you that the atmosphere is able to hold more moisture, and it's able to hold more moisture because the 500 millibar heights are able to expand more, because the stratosphere is contracting faster, because the stratosphere is becoming colder with the reduction of ozone in the atmosphere, which all interacts with what is happening when you add CO2 and methane into the atmosphere. This isn't, again, I don't want to go into politics, all that stuff, but I'm just using basic chemistry, physics, and understanding the environment that we have in play. And of course, then you throw in other factors like volcanoes and geological factors that are beyond our control, and you're messing with Russian roulette there. One thing I never like to mess with. I always say this to my friends: chaos is a real pain, and it's already a real pain in that just by itself. Okay, you don't want to add more chaos to chaos, which is basically what we've been doing. So, just kind of explaining that to you, and just looking at the basic physics of it. Okay, so I hope I answered that question as best as I could. There are large parts of Union County outside of eastern cities of Elizabeth and Rahway that were pretty much all farmland in the early to mid 1900s. And by the way, notice we saw it last spring and summer. Notice this spring and summer, you're going to see more and more thunderstorms with turning motion in locations like around Union County, Monmouth County, Middlesex. This area right here, right around the Delaware River Valley. Why? Well, let's zoom in. I'm going to zoom in here because it shows the topography real well. You see this area right here? You have a declining geological environment here. And what you have here is a lot of microscale and mesoscale wind factors. Actually, here, it would help if I actually showed the map. Okay, so we're talking about this area right here, right? So what you have here is a lot of microscale and mesoscale wind factors here, a lot of natural boundaries. And then you add rising motion because you have a warmer environment on average here. And what that allows is for a turning in the atmosphere. And so that allows you to enhance your thunderstorms more. So as a result, you end up with a situation where your thunderstorms have a greater potential to produce mesoscale low pressure systems, which leads to a greater potential for tornadoes. That's why we're seeing what we're seeing. Not a climate in terms of the large scale climate, wholesale climate, but a change in the microclimate because of the way that we build, which I'm not saying we shouldn't build houses. People got to live, right? I'm just saying that this is just a factor. This is a result of building homes, adding to the urban heat island effect, and thus increasing upward motion of the lower levels of the atmosphere, which leads to that thunderstorm potential. Is the line of moisture showers going to hold up to reach eastern New Jersey? This right here? Yeah, this will probably get here about midnight. This is March and 28 will get here about midnight or so. Okay, let's see what we got here. Pretty good questions on YouTube. I'm pretty much focused around severe weather, which we covered. Am I still mad at Evan and Carlton? No, I'm more mad at the idiot in Philadelphia that was saying, like, I don't know, like meteorologists were hyping up severe event. Look, believe it or not, I do not get a kickback from the milk and bread people, okay? And if I did, I'd probably not be living in an apartment. We'd be living in our own house. And it wouldn't matter that people walk into, when they buy a house, they're just throwing down $500,000 in cash coming out of nowhere. So, no, I do not get paid by the milk and bread people or the oil and gas people or any of those people. I have not gotten a kickback yet. I'm still waiting because apparently that check is in the mail, according to some people. As a meteorologist, you're damned if you do. Yeah, right. As a meteorologist, you're damned if you do, you're damned if you don't. If watches weren't issued, if warnings weren't issued, and someone got hurt, what would be said? Oh, we didn't know it was coming. No one knew it, and we didn't get a warning, and we didn't realize this was happening. We need to have an investigation. And you get the governors and the senators out there, and they want to hold a conference because they gotta look important because they gotta look like they're doing something for the money they're getting paid, which really is really nothing. So you end up in an environment where you get these people making these statements saying like, oh, there's no reason to cancel a game. There's no reason to shut down schools early. In terms of the school thing, that's a new thing in terms of thunderstorms. But my suspicion is that it has nothing to do with the meteorology and everything to do with lawyers, i.e., they're concerned that someone's going to sue them because their kid almost got struck by lightning or something like that. Okay? Or they got stuck in the rain, they got pneumonia, and they're going to sue. So I suspect it has more to do with that than any forecast that was out there. In terms of baseball games, hey, look, guys, we've had multiple scenarios where unfortunately people were struck by lightning from thunderstorms approaching the region and it killed them. So if a team is more proactive in saying, hey, look, we don't want our fans sitting out there in the heavy rain till 9 p.m. to play a game that won't end until 2 a.m. in the morning, I'm sorry, I got no issue with that, I remember the days where you'd have to wait for 9:30 for the game to start at 9:30 on the East Coast and wouldn't end till 2 a.m. That's not a good fan service. And who wants to sit out in the rain? I mean, maybe Evan does, but I don't know. So I think that the whole thing was foolish. And if the Mets, which I've noticed this year, are more proactive in saying, hey, look, we have thunderstorms coming in. We're going to send our fans home or not have them come in at 5 o'clock. And we'll just do a double header, a one single mission double header instead. I don't see what the issue is. I mean, it may be a little bit more difficult to win both games, but in terms of fan service, I don't see what the problem is. So I think that I don't see what the issue is. And to me, it's just It's just something I think that's smart. I think it's smart. I hope that the not only MLB continues on with this, but I hope that really the NFL does this as well. In that you don't have people out there in the metal stands around metal bleachers and metal surroundings with an approaching thunderstorm with frequent lightning. Um, have your fans out on that. I mean, that's just dangerous. Someone could die. Someone has died. People have died with that. And the Mets just got a big double. I'm watching the Mets game too, of course, naturally. Hoping that they win so far. Well, we'll see what happens. So I don't understand some people on social media saying, "Oh, well, we didn't get a severe thunderstorm." What, you want your house destroyed? Look. My insurance agent is a great guy, but I don't want to see him, right? So if you really want to deal with that type of stuff, that's on you. But as far as I'm concerned, anytime I could say, hey, a thunderstorm's weakening, it looks like it won't be as bad as we thought it might be, I consider that a win, personally. So we'll see. But again, the school thing is kind of a new thing, and I'm going to be keeping an eye on it because I have to wonder now whether they're going to start introducing uh, early closing for schools because of heat and humidity, especially in June. Where I went in Free Old Borough, we didn't have air conditioning. Okay, picture this: brick building, no air conditioning, lower 90s, and humid. It was like going to school in a sauna. And you're a teenager who's already kind of self-conscious with everything, right? So now you're sweating to death in there, and they want to know why you can't concentrate to take your test. Oh, I don't know, because I'm probably getting heat stroke. I did a measurement because I was on the student school board, which was a big mistake for the principal who put me on that board, because I think she regretted it after I was put on there, because I did a whole temperature analysis of the high school when temperatures pushed into the 80s, and the temperatures in the school would be pushing to around 90, 94 degrees. And when we got to 90, they were pushing to near 100 degrees. Of course, where they had the new computers, that's where they had air conditioning, where we were stuck at 75 degrees. So what would happen is that you'd create a wind tunnel in the school of the warm air rushing into the cool air. And in the hottest part of the school, temperatures would push close to 104 degrees. And when I brought that down, saying, hey, look, you guys should probably put air conditioning in before someone dies of a heat stroke, they didn't like that answer very much. But it's going to happen eventually. And unfortunately, something like that, you're going to end up where someone is going to get very sick or die, and then they're probably going to put in air conditioning or just close the schools early. So I'm going to be curious to watch to see whether that happens moving forward. Get some more word. Again, if you guys have any questions, just drop them in there. Let's see what we got here for our rainfall coming in. Pretty impressive warm front, I can tell you that. And you can see the mesoscale nature. Let me take a look at a water vapor satellite picture. And you know what? Hold it. I got a better idea. Let's go low level. Okay, there it is. Right there. That little feature right there is what's going to bring us our heavy rain over tonight. Let's see if we see anything in the upper levels. See, in the upper levels it's not as impressive, but you can see with the extent of the tropical moisture. And the mid levels, see a little bit more better, a little bit more definition. And then the lower levels, it really stands out. Let's see if we also have some phonogenesis. Let's do mid-level phonogenesis. Not a lot from the surface to the mid-levels. Oh, there we are. There it's starting to set up. At 850 millibars, it starts to form. And there's our trough right here with a slight negative tilt. Let's see here. In the late 1970s and early 1980s, schools had no AC and did not close or end early for hot weather. That's true. That's true. They also had lead paint. So we've learned some things. Yeah, and you know what? Susan just brought up a great point. They didn't have computers. I tell you, nothing will get the schools to change the way that they work in terms of opening and closing the school than expensive computer equipment burning out because it's too warm in the school. So yeah, that's a good point.
That's where it started. They would air condition the rooms that had the
computers in. That's right.
The rest of the school.
That's right. I remember that it used to be a joy to go to computer class
Or
because
to the office or something.
Yeah, because you knew it was air conditioned. That's a good point. Looking at the satellite imagery, the tools available now as compared to even 5 years ago, much less 10, is just incredible. Oh, yeah. Oh, we've had some amazing advances, and it's only going to get better. So I agree 100%. Is the site with the front's radar shown a paid site, or can the public access it? Oh, great question. This is from WeatherTap. I've been using WeatherTap. It's a paid website. Let's see. I think I pay now with all the added features because I need more data. Like radar data, like in terms of lightning data and whatnot. I pay about $29 a month, but for a basic, I think it was like around 10. But I've been using WeatherTap since about 1998. So I love using this website, and it continues to improve year in, year out. But the radar data I get with it is just outstanding. And I don't get paid. There's no plug here. I'm just telling you, I've been using it for, God, now over 20 years. Oh man, that's that's insane. But yeah, I've been using it for about 20 years, and I have been very happy with it. Now, radar data has improved quite a bit, so the National Weather Service is an excellent source as well. If you just don't want to spend that type of money, it's perfectly fine. Let's see here. So just to kind of wrap things up, a couple of points here. First of all, in terms of the tropics, nothing doing anytime soon. Nothing is on the way. And it looks like, let's see, let me pull up the National Hurricane Center, see what they say. And they generally agree. Nothing really on the horizon either. So there you go. Our next threat for severe weather looks like it's setting up for Sunday afternoon, evening. Certainly something to keep an eye on with our cold front. Tomorrow morning we'll be dealing with heavy rainfall. And it looks like as we head towards the Memorial Day weekend, we will be dealing with a more hot and humid air mass setting up with potentially a backdoor cold front creating some mischief that we'll have to keep an eye on. But definitely some good heavy downpours on the way here. The observations over eastern Ohio is supporting heavy rainfall, anywhere from about a quarter to a half an inch per hour. And it's heading our way and should be reaching our area, I'd say eastern Pennsylvania. Actually, you know what? Rather than guess, why don't I just pull up the HRR guidance? Hey, this weekend you're going to want the ice cream truck around. No. Italian ices. That is where I'll definitely be diving into. Or maybe we'll go and buy some ice cream. What do you think, hon? You want to buy some ice cream for this weekend? We'll see. Maybe. Okay, so this heavy rainfall should start to reach our area. Again, the HRR is really not doing this justice. That's surprising. It's a lot more robust than what the HRR is showing. There's our current observation. As you can see, it's pretty expansive. And this is at close to 9 p.m. And I think that the actual radar is a lot more robust than what is shown here in the HRR, which is interesting. See if that gets adjusted in 0Z. But I would say about 11 o'clock, based on what I'm seeing here on the radar, we'll start seeing it throughout eastern Pennsylvania, and around midnight it'll start to push into New Jersey. The weekend, got that. Okay, so I think we answered all the questions. We talked about everything I wanted to touch on. So, just so you know, moving ahead, we'll have our live chat next week. The first week of June, there will not be a live chat, as I will be indisposed, so to speak. So, there won't be a live chat the first week of June, but I will be making some important announcements leading up to that, so definitely check that out. So that's something that definitely keep an eye on, and let you guys know in terms of some business relationships, some really cool stuff. So I'll let you know about that. Let's take a look at the NAM suggestions. The NAMs is starting to come out. NAM did a better job, much better job, and it's been the most aggressive with the heavy rainfall. So yeah, this looks a lot closer to the reality than what the HRR was showing. And you can see what it does here overnight and through tomorrow morning. Tomorrow morning's rush hour is just going to be so pleasant with plenty of moderate to heavy rainfall. And let's see what that does in terms of total precipitation. Yep. Now, the NAM is the most aggressive out of all the guidance here with this output. Let's see. That's almost 1.5 inches of rain. Let's take a look and see what the new European guidance is doing. It's more robust. Okay, take a look at this. The 0Z for this time period. Not that much, maybe 1/2 inch at most. The 06Z, about the same, maybe a little bit more around Long Island. The 12Z this morning, a little bit more around 1 inch around Long Island. And now the 18Z that's just coming out produces a nice band of about 1/2 inch to 1 inch of rain. I like this idea a little bit more than going full out what the NAM was doing, but you can kind of see how the models are progressing. The NAM might be actually winning this, at least getting rainfall around 1 inch. Again, I like from central New Jersey on southward and southeastern Pennsylvania, and around 1/2 inch to 1 inch around Long Island and the New York City metro. So certainly a wet morning commute is setting up. Well, I think that's everything for tonight. Again, we'll have a live chat next week, same time, same place. And then the first week of June, I will be off, but still be doing forecasts. So I'll still be doing that, but I won't be doing the premium live chat. And then we're back the second week of June. Of course, if there's any tropical development, that may change. So we'll see how that goes. That's it for tonight. Thank you again for joining. And as always, stay safe out there.